Hey everyone, I'm Jacob Strickling and I'm the creator and founder of Tiny Science Lab. Thank you for purchasing one or more of our chemistry sets, and in this short course I'm going to be going through what you'll find in the chemistry sets, the equipment and how it's used. I'm going to show you how to fill and light the Bunsen burner. We'll look at a few important safety requirements to use our equipment safely, and we'll do a few experiments together to explore the potential of what's in these sets. Now, these sets are designed to provide a complete high school chemistry experience. Once you've completed this course, if you haven't already, you can head over to our website www.tinysciencelab.com.au, where you can purchase one or more of our high school chemistry courses, and each course has lots of experiments to do with that particular year level, and by the end of it you will be an absolute pro. So let's get into this set together. The chemistry set equipment. So you will hopefully have a chemistry set that looks something like this. Wash bottles are also very, very helpful. Safety glasses are an absolute must. And you will need to make sure that you buy some butane. This can be bought online from Bunnings. The brand is not overly important. I've bought lots of different brands and so far I haven't had one that's been a problem. And either some matches or a little electric sparky clicker to light our Bunsen burners. So the chemistry set has got lots of different and exciting components. So when we draw scientific equipment in science, we don't use it as an opportunity to show our fantastic artistic skills. Scientific drawings are actually quite simple. They're in 2 dimensions, and what they are is, pretend you get a saw or a knife and you cut the object in half. What you're actually drawing is just the cross section, okay? So use a ruler where possible, a pencil, and the drawings you'll be able to see them here as I show each piece of equipment. So let's get into the equipment now. So the first one we're going to look at is the beaker. This is a 10 ml glass beaker. Now, beakers are not designed to measure volumes accurately. I'll just tell you that now. They're approximate values. Now, beakers are used for heating liquids in. You can even heat solids in them if it's usually if it's a powder or something like that. Very good for stirring mixtures, dissolving, leaving experiments over time. The glass is very, very robust. You can see through it. It's transparent, which makes it very useful. Very easy to wash and very robust. But don't drop them onto the concrete floor, because then you'll find you'll have an empty spot in your in your chemistry set. But Tiny Science Lab does sell every single component separately, so you can always buy components from us if you happen to break them. The conical flask is also made out of glass. It's called a conical flask because it's shaped like a cone. Again, it's used for heating liquids. Great for biological experiments, leaving them over time to grow stuff in. Be careful you don't produce a biological hazard though. And fitted is a rubber stopper, and the rubber stopper is very rubbery and can push in quite firmly, and that can actually be used to stop items falling in, or even to stop stuff coming out that you don't want to come out. So now there's a glass tube with a rubber stopper. Now glass is very, very fragile, brittle, breaks easy. So when you push this in, this rubber stopper with the glass tube in, always push the rubber. Don't push the glass, because you'll end up snapping the glass, and glass glass can cause cuts, and you certainly don't want a piece of glass to lodge in your body. So always be careful when you put on a rubber stopper with a glass tube that you only push the rubber in, like so. Let me put this away. It's very important to keep your sets tidy. When you wash them, when you wash the equipment, just shake the water out, as much of the water out as possible. And then usually you can put the equipment away wet. And if you leave the lid open, then it should dry. It should dry, and then later on you can close the lid and you won't get too much water condensing on the inside. The glass funnel. Beautiful little piece of equipment. It's quite brittle, so be careful not to break it or to exert too much force on it. What you might notice is that the peg holds it beautifully, like so. And later on I'll show you how to use the retort stand, but it actually is held nicely in the peg. So good for transferring liquids. So perfect for transferring liquids. Also, you can put some filter paper in it and use it for filtering, so sometimes called a filter funnel. You can transfer powders, but they do need to be quite fine, and the funnel needs to be dry, otherwise the powder will stick to it. So that's the glass funnel. The measuring cylinder. Okay, measuring cylinders, 5mm measuring cylinders. Later on in another lesson, you'll be learning how to use them accurately. One important thing to do is to have them on a level surface to bring your eye level down to avoid parallax error, and always measure water and most liquids from the bottom of meniscus. So these are 5mm in 0.1mm graduations, and I believe that they're accurate to plus or minus, I think, 0.1mm, so quite accurate. Everybody's favourite, the glass stirring rod. Very, very good for stirring. No surprise there. Not good for banging. If you bang, 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 you'll break. So don't go banging, go stir. Very easy to clean. You can heat them up a little bit, although I wouldn't recommend that, to be honest, but they can certainly go into hot liquids without melting, because glass has got a very high melting point, nicely rounded at both ends. So beautiful. Now there's something called a watch glass. Now a watch glass is about the same size as a watch. Now if you don't know what a watch is, well, look it up on the internet. You can get bigger ones, and they're called clock glasses, because clocks are big and watches are small. But of course, with Tiny Science Lab, we're using small ones. Now, watch glasses, you can put liquids on there, you can put powders on there. Do not heat it directly over a flame though. If you were to use the Bunsen burner and heat that directly, it will crack. Okay, as it expands, the middle where it's heating, it will expand, and the outside will be cool and contracted. It's guaranteed to crack. So you do not heat these directly. But later on, we're going to learn how to heat them with a water bath, and very good for evaporating our solutions to find out what the dissolved substance is. So that's our watch glass. Test tube. Test tubes are very, very important pieces of equipment made from glass. Great for heating chemicals, liquids, storing chemical or experiments over time. They can be washed with water, and there's a test tube brush that can be used to wash your test tube, and the brush can also be used to wash your beaker or your conical flask or your funnel. Okay, so test tube and test tube brushes are very, very helpful. And little plastic plate is great for putting chemicals on. And talking about plastic, there's also a 20mm plastic container, which is also quite helpful for using with our sets. The tiny spoon. Everybody loves the tiny spoon. Very good for distributing chemicals, powders. Not good for getting wet. Okay, do not use this spoon to stir. That's why we've included the stirring rod. Okay, if you do get it wet, make sure you wash it in clean water and dry it very, very quickly. If you get chemicals that are stuck to it, like copper sulfate, make sure you you wash them and you dry it to keep it clean and to make sure it doesn't corrode. Okay, so look after your tiny little spoon. They're actually fairly expensive to buy. They're just not a normal like metal iron spoon. They're actually quite special, so do look after it. The wooden peg. Okay, so wooden peg, it's a insulator of heat, so heat doesn't travel through it. So you can use it to hold something that's hot without burning yourself. Now, I've shown you that it's very good for holding a funnel, and it can also be used to hold a conical flask. Now, it is possible that the peg sort of like separates from the metal or something like that. It's got a little spring in there. Whoa! See? Mine just separated. Now, that doesn't mean it's broken. You can actually fix it quite easily. Okay? It's an easy fix. You just put the parts together. And with a little bit of effort, not a lot of effort, you can actually, let me see if I can do it right here, live on camera. Ta-da! There we go. I fixed it. It's not broken. It's almost impossible to break them. They will fall apart, but you can put it back together. So don't say my peg's broken. No, your peg just needs putting back together. Okay. Then we've got the mortar and the pestle. Now, how do you remember which one's the mortar and which one's the pestle? Well, the mortar holds water. Hear the rhyme there? Mortar holds water, although you don't usually put water in there. Normally you put in powders that need to be ground up. Okay, so you might have a, maybe like some sodium carbonate decahydrate, and you will pop that in and you might grind it to a powder. Now, when you grind chemicals to a powder, that increases their surface area, which probably will increase their rate of reaction when you do a chemical reaction with them. Now, it's probably best to wear safety goggles when you're grinding things in the mortar and pestle, because it has been known that that energy, that heat of grinding can actually cause the chemical reaction to occur with some chemicals, can cause an ignition point, and so just be safe, and if in doubt, always wear safety goggles, or even when not in doubt, wear safety goggles. The heart of our system, the Bunsen burner. Okay, absolutely wonderful piece of equipment. Changes the chemical potential energy of the butane into heat energy. Now, whenever I take it out of the case, I always like to just hold the top and just rotate. I'm just making sure the top metal part is tight. Okay, so sometimes it can become loose, so you just need to make sure it's tight. It's also important to have a little look to make sure the top, that it's clean, and it's very important to keep this part clean. Now, it is possible to wash it with water and then to dry it, okay, if it does get any bits and pieces of chemicals in it, but the best thing to do is not to get any bits and pieces of chemicals in it at all, because you really want to look after this Bunsen burner. Now, the Bunsen burner, it fits into the table when the legs are out, you'll see after on. So, Bunsen burner, beautiful. Then there's two heat-proof mats. There's one heat-proof mat that goes over the Bunsen burner, and there's one heat-proof mat that goes sitting on the table. Now, these are to put hot things on. These will protect your table from getting burnt. Now, if your table does get burnt, doesn't matter. Bit of black, black charring here and some scratches and some chemicals here, or make it look used, which is wonderful. I don't want to see pristine tables. I want to see used tables. That shows that you're doing chemistry. So you can wash them with water. Over time they will get stained and even scratched, but they'll still function as heat-proof mats, so that's good to remember. The tripod. Triangles have got 3 legs, and the tripod has got 3 legs, and they're actually cut from steel, and the legs are welded in, and these are used above the Bunsen burner. Now they can get quite hot. They will get quite hot when the Bunsen burner's on, so I always usually like to handle them with the tweezers, which I'll show you later on. Now, don't put them back into the foam hot, because they'll melt the foam. Okay, so don't put them back into the foam hot. It's usually best just to let them cool down naturally over time. And what you'll find is that this tripod will probably go rusty over time. Now, if you don't like the rust, that's fine. You can get some sandpaper and sand it off. But some of you will like the rust because it sort of looks, I don't know, authentic. So totally up to you whether you want to keep it rust-free or not. The wire gauze, which can be found under a heat-proof mat, is used to go onto the tripod, like so, and is used to distribute the heat of the flame. So again, it gets hot, and so you'll handle it later on with the tweezers, okay, so that you don't burn yourself. Speaking of which, if you do burn yourself, go run your burn under cold water and seek medical attention. So now I've mentioned the tweezers a few times. Now your tweezers probably will have a little rubber tube on them, and that's to keep them closed. And whenever I take the rubber tube off, I actually put it in the end where the tweezers go, so that I know where it is. Now the tweezers are a very helpful piece of equipment for our chemistry sets. The tweezers can be used to pick up the tripod. The tweezers can be used to pick up the wire gauze. Now, with the Tiny Science Lab, I actually use the tweezers to actually handle the glassware as well. Now, normally with regular size equipment, I'd say don't do that. But with our equipment, actually handling the glassware with the tweezers seems to be quite fine. You can even hold the conical flask, although what you will notice is that it does have a little bit of it does sort of like pivot in there. So it's not as good. The tweezer's not as good as the wooden peg, but still, well, look, in fact, look, if I hold it, there we go, there we go. If I hold it closer towards my hand there, look at that. That's actually fairly firm in there. So if you are picking up the conical flask with the tweezers, maybe hold them further away from the end. So tweezers, excellent. And before I put them away, I will put the little rubber tubey on and then pop them back in there like that. Now, that brings me to the thermometer. And the thermometer is accurate to 1 decimal place. Well, it shows 1 decimal place. So this reading is actually 16.4 degrees Celsius. There's a little tiny point there. So it's in Celsius, not Fahrenheit, and there's a little point there. Now, you might have a little cable tie on yours, or you might not. And this is actually called, this little silver part here is called the probe. That's called the probe. And that's the thing that you put where you want to measure the temperature. Now that probe can go in boiling water, okay? In fact, it's okay if this lead goes in boiling water, but don't heat this lead up with the Bunsen burner, because it's just made out of rubber, and the plastic will burn and melt, and then you'll have to buy another thermometer from us. So very, very good, very, very handy, great for measuring all sorts of temperatures in the fridge, the freezer, in your experiments, outside in the sun. Lots of experiments can be done with this. Now, eventually the batteries will go flat, okay, because it's always on and you can't turn it off, so the batteries will go flat. So to replace the batteries, what you do is you grab the lead and you give it a little bit of a yank, and it pulls out like this, And there's two LR44 button batteries that you can replace them with. Then you pop them back in. Make sure you dispose of the old ones carefully. Make sure they are kept away from young children because they look a little bit like lollies, and we don't want kids to swallow those button batteries under any circumstances whatsoever. So keep the button batteries away from little children. And then you can find out from your local council's website how to dispose safely of your button batteries. So let me pop that back in, and that can be washed with water. That probe can be washed with water. So then we've got some scales. Now these scales are quite special, very, very accurate. Always put them on a firm surface, fully on a firm surface. These are not a toy. These are actually quite a precision scientific piece of equipment. I'll open them up. Now your hinge might, they're actually designed to take this plastic case off, but sometimes the hinge is, doesn't go click on perfectly, but that's okay. Then once it's all firm and there's no bumping, then you can turn it on and you wait. Just wait. It'll take some time to settle, and then hopefully it should read 0.0, there we go, 0.00. So just be patient. If you want to weigh something, you can gently put something on there like that. It says it's 7.97 grams. You could put a plastic plate on it there like that, 2.64 grams. And if I wanted to weigh out like a gram of, say, copper sulfate, then I'd use my tiny spoon. Now, what I would do then is I'd put my plate on, and then I'd press the tare button, T-A-R-E. That brings it to 0. Then I can weigh out my copper sulfate or whatever substance. Now, you would not normally put any chemical directly on the surface of that metal plate, okay? You always put a chemical into a container and weigh it like that, okay? So don't put chemicals directly onto those plates. The scales do not like that at all. Then you can turn them off and then close them up and put them back into your case. That brings me to the retort stand. Now, I personally have designed this retort stand. I think it's much better than ones found in schools. Notice that you've got a fitting here that slides up and down. It's a friction fitting. Okay, there's no knobs to turn and twist and that sort of stuff. It's a friction fitting, and you'll find that this black end piece slides in and out as well. Now, you might be thinking, doesn't that mean if that is a friction fitting, won't this just come down over time? The answer is no, because when you apply the weight here, it causes it to twist here, and that twisting increases the friction. Now, let's say I want to hold the funnel. I want to hold the funnel. Then I will get the red fitting, okay, the little red fitting, and I will push the peg into the fitting like so. So the red fitting holds the peg, and then I'll push that into the end of the this, I guess you could call it the clamp, and then I can put the, hey! And so if I want to adjust the height, I can bring it down like that. I can bring it up, and I can slide it in, I can slide it out. How good is that? That's the retort stand. What else can I hold with it? Well, if I take out the peg and change the fitting to the blue fitting, like this, okay, pop that on. Yay! There we go, that's holding in place. And this time to that fitting. Yay! I did it! There we go. So you can actually use the blue fitting to hold an open peg like that. So, very helpful piece of equipment, the retort stand. Another classic use for it is to, if I take that peg out and swap it around again, swap, take this, it's just a friction fit, and if it doesn't fit in that well, just push a little bit harder. And it's very useful to hold the probe. Okay, so it's actually very, very useful to hold that probe, that temperature probe, in a beaker of liquid. So, excellent, excellent. Now, I love to make sure that the equipment is always put away in its spot. So, if you put it away clean, and you put it away in its spot, then it's very easy to use the next time you get your equipment out. So, now, there's a plastic pipette. Is next, and if I get a little bit of water into a beaker, plastic pipette is used to, you squeeze the bulb and then you release the bulb and water will go up into the plastic pipette, and you can release it dropwise, drop, 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 count the drops, or you can give it a squeeze. And there are some measurements along the side here. Now you've probably got a 2 mil pipette, and I think that it's graduated in half mil graduations, so like half, 1, 1.5, 2 mil. Now, it is important to recognise that these plastic pipettes are not really accurate either, but very good for transferring liquid. Now, I've got a little bit of liquid in this beaker, and so I usually have some type of container that I use as a waste container. So, now, the wash bottle. It's not a water pistol. Do not squirt anybody ever with any piece of equipment from this set, because, you know, someone may one day use, you know, an acid or, you know, something corrosive or caustic, and if you go and squeeze that water, which you think is just water, you might actually spray something nasty on them. So none of our gear is a toy, so don't muck around with it, please. Now, you should have some water in it. And the best way to use a wash bottle is to hold it vertically and then just to squeeze, and water will come out the top. Okay? So that's how we use a wash bottle. A rubber tube. The rubber tube can be cut to length, and the rubber tube will fit over the glass tube for different experiments. That's the chemistry set equipment, and I hope that when you use it safely and carefully, and that it will enhance your enjoyment and learning of science and chemistry. Bye for now. Hello everybody. In this lesson we're going to be looking at hazards and risks. Now, hazards are anything that have the potential to cause injury. It could be sharp objects, it could be chemicals, it could be hot objects, it could be things likely to explode. But it could be a trip hazard, it could be a slip hazard. Lots of hazards in today's society. Now, a risk, though, is the likelihood for a hazard to cause injury. So, I've just blown out this Bunsen burner. What's a hazard here? Well, if I'm going to protect my eyes from any possible hazard that could affect my eyes, which I guess could be some hot water spurting out. What's the risk of that? Oh, quite low, but I'll put my safety goggles on anyway. Let me turn this gas up. Oh, there we go. All right, now, a hazard is a hot match. So I'll put the hot match on the heat-proof mat. So a risk is how likely that hazard is to cause injury. Now, let's have a little look at this setup here and look at the hazard and the risk factor. Now, a hazard obviously is the hot water in this beaker. Now, because there's only a little bit of water, the risk is low, and because it's actually not that high off the table, the risk is also fairly low. The hotter it becomes, the greater the hazard, and the more likelihood it is to cause injury. So look at that, bumping away there. I'm going to turn that heat down now. There we go. Now it's sort of just boiling gently. But did you notice that I was using my tweezers to move some of the equipment around to help keep it safe. So we've got glassware that, you know, it's hazardous if it breaks, because glass broken is sharp and can cause cuts and injuries. I've got a wire gauze here. Let me show you the wire gauze. Oh, and it's actually glowing. Whoa! Whoa! Oh, let me fix this up. Oh, what a disaster. There we go. Oh, that's better. So I'm handling the wire gauze with my tweezers because of the heat. The tripod itself is made from metal, and so that's a hazard. You know, how sharp are the edges? You can consider that. Is it hot? Yes, it is. What's the risk factor? Fairly low, because I'm, you know, if I did get burnt by it, I'd just go and run my burn under cold water, and the injury wouldn't be too severe. So, I don't want to overrate the risk. And we've got a flame there. Now, that flame can be quite dangerous. Its risk factor is relatively high, but we can do things to reduce the risk factor. For example, just putting the wire gauze over there. Now, have a look at this conical flask with the rubber tube and the glass rod. Is that hazardous at all? Absolutely, absolutely. Because this is really, really quite firm and sharp. If I came down quickly with my head, I could actually poke that into my forehead or into my eyes. So sometimes there's hazards that aren't obvious, and they're sometimes the most dangerous ones, the most risky ones, because you don't really realize how dangerous or hazardous they actually are. So always, yeah, glass rods, glass tubes are quite hazardous, so take care around them. So ways to reduce risk. Obviously, I've had a look at some things already with you, but ways to reduce risk with the Tiny Science Lab is to handle our equipment with tweezers rather than your hands. Even if you don't think it looks hot, I like to get into that. Like, this tripod doesn't look particularly hot, yeah? But I wonder if I put a little bit of water on it. Whoa! See that? It did not look hot, but in actual fact it was very hot. So, see that steam? Right, so that should be a good point of warning for you. Whenever I have my Bunsen burner on, once I've lit it, it's very good form, in my opinion, to quickly put the tripod and wire gauze over the flame as soon as you possibly can. Whoa, there we go. Because a flame like that is actually quite risky, whereas if I put the tripod there, all of a sudden that sort of forms a little bit of a barricade, and then the wire gauze diffuses the heat. Lovely, rendering it very, not particularly risky at all. Using the Bunsen burner, always use my safety glasses, and if you keep all these things in mind, you actually can have a quite safe experience with the Tiny Science Lab. All science experiments are inherently dangerous. The good thing about Tiny Science Lab is the risk is much lower. Why? Because the volumes are much lower, so you're using less hot water, you're using less chemicals, and so that's a number of ways where Tiny Science Lab equipment reduces risk. Anyway, hopefully you enjoyed this lesson, and I look forward to seeing you again soon. Bye for now. Hey everyone, in this lesson we're looking at PPE, Personal Protective Equipment. Now, do you want to know what I think is probably the most important piece of PPE in chemistry? You're probably thinking like safety glasses. Well, I actually think it's this thing, This is a hair tie, and I have seen more accidents with long hair getting burnt in Bunsen burners in schools than I have seen kids being damaged with their eyes. It is very important that you tie your long hair back with a hair tie so that there is no hair hanging in front of or on top of a Bunsen burner flame. Hair is actually very flammable, so make sure you tie your hair back. Obviously, I don't have much of a problem with that given my fairly short hair, but if you've got long hair, and I'm even talking about wisps of hair coming from the side here, make sure you tie them back. I don't want to see you catching on fire. Anyway, but safety glasses are also very important, and probably the worst incidents I ever had was a time when I wasn't wearing them, when I wasn't expecting for something to happen. I had a can of paint, and I was shaking the can of paint for quite some time. It was heavy zinc galvanizing paint. I was shaking it. I didn't have safety glasses on. I didn't think I was going to need them. I opened up the can and it sprayed my face. Now, thankfully, I was able to close my eyes just in time, but where the paint hit my skin, it actually burnt. It really hurt. Had my eyes been opened, I'm sure I would have had some serious damage there. So, unexpectedly, that's probably when you need your safety glasses the most. When those things the surprises that occur. It could be a rubber stopper blowing off a test tube or something like that, or a chemical spurting out when you least expect it. Safety glasses protect your eyes, so very important. Now, I don't normally wear lab coats. The reason I don't normally wear a lab coat is I actually don't like doing experiments that would ever actually need a lab coat. I don't like to do experiments that are going to spray and shoot stuff off and, that I have to protect my clothes. I actually like to do experiments that I'm almost 100% sure are going to be perfectly safe and perfectly contained. But if you do wear a lab coat, make sure it's a good lab coat, because I'm going to show you that not all lab coats are the same. In fact, some lab coats are actually more dangerous wearing the lab coat than if you didn't have the lab coat on in the first place. How is that possible? Well, it's because some lab coats are actually quite flammable. So I brought these relatively cheap lab coats for Tiny Science Lab, and way too cheap. And the reason that they were so cheap is that they're made from a synthetic material based from petroleum. And let me show you what happens if you hold it in the flame. Are you watching? Look, here we go. Whoa! Look at that. See that hole? It just melted a hole straight into it. Whoa! And if I hold it on a little bit longer, look. Whoa! See that? Oh, quite flammable, quite toxic, and that actually burnt really quickly. Let me do that once more. Imagine if you're wearing that, right? Imagine if you're wearing that and it caught on fire. Whoa! See that? That burning plastic, that would stick to you, right? Very, very dangerous. Especially, look at that, it's catching. I'll blow it out, and it's become quite sticky and hot. This would cause some serious injury to your skin. So it's probably made out of nylon, and so definitely a no-go. This is a better one. It's heavier duty, and I'm fairly sure that it's made from cotton. Okay, I'm quite sure that there's a lot more cotton involved here, which is not synthetic. And I'll get the base of it, and let's have a look to see what happens if I hold it in the flame. What happens if I hold it in the flame? Oh, flame's gone out. So let me just quickly relight that. go. And hold it in the flame. Let's see what happens. Ooh, that actually that actually burnt quite well too, didn't it? Oh dear, oh dear, oh dear. Whoa, whoa, that's probably even worse. Oh, I really don't know my lab coat material, do I? That probably goes to show that you probably should assume that every lab coat is flammable, right? And if you're wearing a lab coat like so, see how this sleeve is hanging down? I would not have that sleeve hanging down like that. I would probably put the sleeve up like this so that you don't have too much loose material hanging around to get burnt. Oh wow, I don't think I'll ever trust a lab coat again in terms of flammability. What a disaster. Okay. Anyway, what's also very important, heavy duty shoes, usually made out of leather, so that if you drop a heavy beaker, now we don't really have any really heavy beakers or really heavy equipment, but sometimes you might accidentally tip some chemicals or something, and then a pair of enclosed shoes is really good. And some people really like to wear gloves. Again, I'm not a huge glove wearer because typically if I'm dealing with some chemicals and I feel my hands get wet, then I just go wash them. I assume that if anything goes on my hands, it's dangerous, and so I just go wash them off in water. I have had it once where a teacher was helping me make liquid nitrogen ice cream, and he had gloves on and he was stirring it, and the gloves froze, and then they sort of froze his fingers a bit and he got a little bit of frostbite. Now I know that if you're not wearing gloves, you actually feel it get cold, and so you actually move away. And so, it's up to you whether you think it's important to wear gloves, but just beware that also some gloves can be flammable as well, particularly like rubber gloves. And so be careful with the PPE that you're wearing, that it's actually not going to cause you more harm than if you weren't wearing it. So my two favourite pieces, of course, are safety glasses and hair ties. Very, very important. Okay, well, hopefully you've enjoyed this lesson, and I look forward to seeing you again soon. Bye for now. Hey everybody, in this lesson we're going to be learning how to light a match the Tiny Science Lab way. And that is a safe way, particularly if you're in a group of students using this equipment. And so you might be sitting quite close to each other. Lighting Match the TSL Way will be a great way to go. So for this activity, you're going to need your heat-proof mat, some safety glasses, a box of matches, of course, and it will be handy to have your tweezers ready. Now, the tweezers have got a little loop there, and that loop keeps them closed, and so I always put that loop back in the slot in the foam case so that I don't lose it. All right, so I'm going to put my glasses on, and this part of the matchbox is called the strike plate. The strike plate. Now, in the olden days, matches didn't need a strike plate. You could actually strike a match on almost any surface. You could strike it on a window, you could strike it on the bottom of your boot. I saw a movie where a cowboy struck it on the stubble of his cheek, and all that striking produced heat from friction, and that heat was enough to ignite the chemical in the match. Now, fast forward, 100 years or so, and now we have something called safety matches. Now, just because they're safety matches doesn't mean they're safe. A safety match can still burn down a bedroom or even a house. So the reason it's called a safety match is because you need both the match and this special strike plate to ignite the match, because the strike plate actually contains some chemicals as well. Oh, look at this, my glasses are fogging up. So I'm just going to get the corner of my shirt, and I'll use the corner of my shirt to wipe the glasses, and that's better. Now, I like to put the heat-proof mat in the centre of my table, and then I aim the strike plate towards the very, very centre of the heat-proof mat. Now, I hold it at quite a steep angle, and then the match itself, I actually hold red end down, and I actually hold it vertically, and I'm actually going to strike down vertically. And you'll see that the match lights very easily. Are you ready? Strike down. Strike down. Hey, look at that. I get it burning, and then I hold it horizontal. Okay? So once it's burning, hold it horizontal or upwards like that, because otherwise, I've seen kids, they keep holding the match like that, and you know what happens? Ah! They burn themselves. And if you do burn yourself, run your burn under cold water. Now, the burnt match, I'm going to put here on the corner of my heat-proof mat so that it doesn't damage the table. Let's do that again. So, get out a match. I will hold it with the strike plate aimed towards the center of the heat-proof mat, and I'll strike straight down. I'll get it burning, and then I'll go horizontal like so. So if you get it burning well, then the match doesn't go out terribly easy, which is really, really good. Now, this is a chemical reaction. It's producing light, it's producing heat, it's producing a new substance. I can see black charcoal now. All classic signs of a chemical reaction. This is a non-reversible change or an irreversible change. Ooh, a little bit of smoke. Now, why is this safe? It's safe because, well, nothing is really safe, but it's a safer way to light a match, because I've seen kids who light a match where they flick it like this, and I've seen the burnt match heading off and landing on the lap of another kid. If you strike it towards yourself, I've seen little burnt matches like land on the person's shirt. But if you hold the strike plate towards the centre and you strike straight down, you're almost guaranteed to light the match, get it burning well, and then you can hold it horizontally. Now, we can have a little bit of a challenge if we want. Let's see who can actually burn the match for the longest. So I'm going to get out my mobile phone stopwatch, and I will put it on stopwatch, and it's on the clock. There we go, and the stopwatch reset, it's ready to go. And the question is, who can actually burn the match for the longest without burning themselves? And this is where you need to have your tweezers at the ready. So, are we ready? Once I get it burning, I'll press start. Okay, that's burning, so I press start. I'm now going to hold it in my tweezers, and look, you can actually see the time happening there. And so you sort of have to hold it horizontal. You don't want it to burn too quick, because the challenge is who can make it burn the longest. Is mine going out? And mine's out. Oh, my stopwatch didn't work. Oh dear, oh dear, oh dear. Or is it working? Oh, it is working. It is working. I think it was about 32 seconds. No, a bit less than that. So I'm going to do it again. Let's just call that one a practice round. Nothing wrong with having practice rounds. Okay. Yeah, that was definitely just a practice round. Okay. Light my match. Press start. And I'm getting it burning. Okay. Let's have a look this time. Oh no, the flame was too big there. It was burning too quickly. You want to find that balance of just burning. I don't want it to go out. Yeah, I want it to burn all the wood. I think last time I got about 28 seconds, to be honest. Uh-oh, got it burning again. Don't go out, don't go out. Oh, what do we got? Oh, it's not too bad. I should stop talking because get that last little bit of wood, and it's out. 44 seconds. Yay! Oh, that's not too bad, I think. 44 seconds. How did you go? Okay, how did you go? Friction, very important. Friction is a force that resists motion, but if you rub your hands together, you will notice that it gets warmer. Yeah, your hands get warmer. Friction forces often produce heat. Yeah. Now, when you do that previous experiment, it's best to actually repeat it 3 times, and then you add those numbers, those times together. You divide by 3 to get yourself an average. Okay, that's how we work out averages. You add up all the numbers, and then you divide by how many there are, how many numbers you added up, and that will give you the average. Now, one of the chemicals in the match head is red phosphorus, or phosphorus, and phosphorus is an element. But phosphorus can actually take on some different physical forms. Phosphorus can actually take on being a red phosphorus, something called red phosphorus, and white phosphorus. Carbon is an element that can actually be like diamond, black soot, graphite. It's got what we call 3 allotropes. Allotropes are examples of the same element but with different physical properties. And the physical property might be its boiling point or its density, even its colour. I put it to you that you should research what an allotrope is and how it relates to matches and red phosphorus and white phosphorus, because that will give you a better idea of how a safety match works. Okay, hopefully you've enjoyed this lesson, and I look forward to seeing you again soon. Bye for now. Hello everybody. In this lesson we're looking at filling and lighting the Bunsen burner. So this is the Tiny Science Lab Bunsen burner. It's got a fuel reservoir here which holds the gas. That goes beneath the table, and the little Bunsen burner part sits above the table. Now the gas required is butane. Butane is a hydrocarbon, and I'm going to make a model of it. Now this black ball represents a carbon atom, and I'm going to push into it 4 hydrogen atoms. Now these 4 hydrogen atoms and 1 carbon atom form the molecule methane. Now methane is a flammable gas, belched out by cows, and it's actually belched out by humans from the other end. But if I get a second carbon atom and now place another 3 hydrogen atoms so that the carbon atoms are fully surrounded by hydrogen, now I have ethane, a molecule of ethane. And ethane is one of the precursors to making polyethylene bags. So let's now take off one of these hydrogen atoms so that I can bond to it a third carbon atom. And so let's fully surround that by hydrogen atoms. And I've got a little cute little doggy. Woof woof. Woof woof. Now you can do this with plasticine model molecules. Now the correct name for this is propane. So we've had methane, ethane, propane. And propane is your barbecue gas. It's what you get in those bottles that you can get refilled. Propane, liquid petroleum gas, is mainly propane. Which finally brings us to butane, which if I add 1 more carbon atom, so that I have 4 carbon atoms surrounded by 10 hydrogen atoms, chemically bonded together, I now have a molecule of butane. Okay, there's a molecule of butane. And if I want to draw it, which I do, okay, let's draw that molecule of butane. And this is just going to be a very simple ball and stick model. Very, very simple. 4 carbon atoms, so I call it C4. And then if I get 10 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got C4H10, and that is our model of butane. And when I have trillions of those molecules, that's what makes up this liquid. Now this liquid quickly goes into a gas, which is why these Bunsen burners use butane, because under a little bit of pressure, it's a liquid, but then if you release the pressure, it becomes a gas, which makes it very useful for Bunsen burners. So I purchased this from Bunnings. Now you can purchase it online. Now I have bought quite a lot of different brands over the years, and I've found every single brand has worked very well in these Bunsen burners. So how do we fill up the Bunsen burner? Well, a homeschool student showed me this. I think this is the best way, where you put the Bunsen burner upside down into the hole in the table so that it's quite firm. And I take off the lid, and I'm actually just going to use, I don't actually need the adapter. Now sometimes you'll see adapters in the lids, but I've found that that size actually fits our Bunsen burners. Now I will be coming vertically straight down, and once I engage, I will just give it a firm push and hold it there. Now we might get a little bit of gas coming out. A little bit is okay, but we don't want too much coming out, otherwise it means you haven't seated the valve in properly. Also, I want to make sure that nobody has got a lit Bunsen around us, or that there's any flames around us, because the gas that might escape is quite flammable, so we have to be very, very careful. And then the final thing is, we don't need to overfill the Bunsen burner, okay? We just need to bring it up to about 80%, 8/10 the way up. In fact, I'm not even going to bring it up to about 8/10. You'll see what I mean when I fill it up. Okay, so here we go. I'm going to hold the base with my left hand, the can with my right hand, push down firmly, and that's full. Even though there's a gap up the top, that's fine. 80% is perfectly fine. This will give at least 20 minutes of burning time. So yeah, don't overfill these, please, because otherwise they might not function properly. So we now can put it in the table, but what I want you to notice is, pretend your left hand is the table, and you're going to hold the black ring. Well, when you turn on the gas, I actually have to turn it clockwise to turn on. So rotate to turn it on, and then anti-clockwise to turn it off. And what you'll notice is that there's a little bit of a lump here. That's called a key. And there's a hole in the hole, so to speak, a notch out of the hole, and that key goes into that notch. And that will allow us to rotate the base without the whole thing turning. So there we go. It's in the table now, and I'll be able to adjust the gas with my left hand. I'm going to put my goggles on, like so, and I'm going to get out my solid heat-proof mat, which I will put near the Bunsen burner. I will put my heat-proof mat with the hole in it over the top of the Bunsen burner, like that. And I'll probably get my tripod ready and my wire gauze ready for once I've actually lit it. So we can use our matches, and you know what, I usually like to get the matches burning before I actually turn the gas on. Now when I do turn the gas on, I only give the bottle about half a turn. So I'm going down here with my left hand, I'm grasping the base of the Bunsen burner, and I'm rotating. Now you don't need to have it on full. In fact, it won't work very well on full at all. The gas will blow out the match. So usually I just have it so that it's just audible. Okay, just audible. And so I light my match, and I aim my strike plate towards the center of the heat-proof mat, and I strike straight down, and now the match is lighting. I bring it to the side. I bring it to the side of the Bunsen burner, and I could tell that the gas was too high to start with. It was blowing out the flame, so I reduced the size of the amount of gas coming out. And I can make the gas go low, I can make the gas go high, and just get used to rotating it with your left hand so that you feel full control of the Bunsen burner. Let me do that again. I've turned the gas off. It does take a little bit of time for the gas to stop coming out once you have turned it off. And let me light my match. I wait till I have full control of the match, that it's burning quite well. There's no rush at all. And I slowly increase the size, the amount of gas coming out by rotating the knob. And very simple to light, very simple to light. Beautiful. Very nice flame. And it's important to put the tripod and wire gauze over as soon as possible. Now, there are a lot of benefits to lighting matches. It's good for learning. However, matches, they cost money and they produce waste. And so Tiny Science Lab actually sells this beautiful little clicker. It's a little piezo clicker which produces a tiny little spark. Let's see if you can see the spark when I click it. I'll hold it still and you see if you can see the spark. Can you see the spark there when I'm clicking? We'll find out later. But let's see if I can use this to light my Bunsen burner. I put it on the top in the middle, turn on the gas, click. Oh, look at that. I'm going to do that again. Click, click, yay! Once more. So if you don't want to buy matches, you can buy one of these clickers off us, and it fits very nicely in the set where the test tube brush and the plastic pipette are. Very nice indeed. So, safety precautions. As I've said, once you've lit it, put the tripod on and the wire gauze, and then that stops you from putting your hand over the Bunsen burner flame and burning yourself. If you do burn yourself, put your burn under cold water and seek some medical attention. So I hope that you've enjoyed this lesson of filling and lighting the Bunsen burner. A very key takeaway is to only ever fill your Bunsen burner up 80% and not to overfill it. Okay, I look forward to seeing you next lesson. Bye for now. Hey everybody, in this lesson we're going to be looking at the Leidenfrost Effect with an ice cube. So the Leidenfrost Effect, it's a wonderful combination of liquids and gases and some amazing interactions. So let's check it out straight away. Now I'm going to need my safety glasses, your Bunsen burner, tripod, wire gauze, and a steel pan from your set. Now you can use the aluminium pan, but it might melt, so I like to go for the steel one, and that's the one that's magnetic. Now the first thing I'm going to do is light up my Bunsen. Wonderful. Put on my tripod and wire gauze. Lovely. And I'm going to need a little bit of water, and I like to have coloured water, so let's put some water here and a little bit of red food colouring. Wonderful, beautiful. And I'm going to put on my steel pan straight away like that. Now it won't take long for that steel pan to heat up. It's got to be very hot for the Leidenfrost Effect, because if it's not hot enough, you'll just boil water. But if it is hot enough, then something amazing will happen. So I'm going to press record on this side camera so that we can see the action up close. I think this will be hot enough now. So let me get a drop or some water up into the pipette and add it to the, whoa, straight away we're getting the Leidenfrost Effect. Look at that, a nice ball of water. Whoa! And That pan is really, really hot. Look at it move around when I blow it. Oh, it's like a little race. Around we go, round we go. Woo! So what's actually happening is the bottom of that drop is actually boiling, producing steam, and then that steam lifts the drop up off the pan, insulating it from the heat. Now it will get smaller and smaller over time as it... Oh no, we just lost the Leidenfrost effect. It's got to be very, very hot for the Leidenfrost effect. Whoa, I just lost my heat. Now, if you keep losing your heat, the best thing to probably do is to actually get rid of the wire gauze. So I'm going to remove the wire gauze and put the pan on like so, and it will be easier to sustain the Leidenfrost effect. Oh, that didn't sustain it very good at all. Let's try again. Yay, there we go. Oh, I'm getting it quite big and moving it around like that. Fantastic. Now, the big question is, can we do this with an ice cube? That is a very interesting question. I'm going to tip off that, that ball of water. And for it to work with an ice cube, we definitely need to get it super, super, super hot. So that's what I'm going to blast it now with the Bunsen burner. Wow, it's going to get very, very, very hot. And I'm going to pick a small ice cube, and hopefully we can do the Leidenfrost effect with an ice cube. Are we ready? Are we steady? And on we go. Oh, it was so, so close. It was so close. I had it there. I had it going for a moment. Okay, I had it going for a moment, and then it sort of like disappeared, the effect. So I'm really blasting that with heat. That is going to get super, super hot. Let's get another ice cube. Hopefully I can get a really small, small one. Okay, let's try this one. Okay, I can see that glowing red, and are we ready? On it goes. Yes, yes. No! No! Oh, oh, come on. Let's try a smaller ice cube. I've got a massive ice cube tray here. What I might do is just drop the ice cube in the water for a moment, just to make it a little bit smaller. Okay, just to reduce the size of it so it doesn't quite have the same volume. And that's really hot now. Okay, all right. If this doesn't work, then nothing will work. Ready, set, go. Yes, 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 and success. Look at that. We have achieved the Leidenfrost effect with a tiny ice cube. Fantastic. Oh, that's wonderful. Now, if I turn off the heat, the pan will start to cool down. But you know what? That tripod is super, super hot. So I'm actually going to squirt a little bit of water on the tripod to cool the tripod down. You look at this. Look at the heat coming off that tripod. And in a moment, that water droplet will lose the Leidenfrost effect. Because I'm removing... Whoa! There we go. How good was that? So, yes, you can do the Leidenfrost effect with a small little light globe, ice cube on very high heat. Now, let's look at one of my next favorite demos, and that is water pump up. Now, for water pump up, I need to put the wire gauze back on, and I need a full beaker of water, and coloured water is fantastic. And we need our little conical flask with a little bit of water in it. Not a lot of water, okay, just enough to cover the base. So less than a mil, but just enough to cover the base. And I'm going to put this glass tube in with the rubber stopper. Now, always push on the rubber stopper, not on the glass, okay? Because otherwise you might hurt yourself if the glass breaks unexpectedly. And let me click that up and put this on like so. And now let's get this happening. Now that's cold water, and above it in the conical flask is just air. Now we want to somehow get rid of the air, and the way that we're going to do that is by boiling that water, and it won't take long to boil at all. In fact, I can actually, if I really blast it, that water's going to heat up. I can actually see some condensation happening here, which is very exciting. And there we go, that's boiling nicely. Okay, that's boiling nicely. Filling it up with steam. See that? Filling it up with steam. And the steam is now coming out, and that steam is actually carrying out the air. So now it's just filled up with steam. I've had a phase change, just change the state from liquid to a gas. And I'm going to now flip this upside down into that beaker. So are we ready? And keep your eyes on the conical flask. Around we go. Keep your eye on the conical flask. Woo! How good is that? The water is actually pushed up. The water is pushed up because when the steam condenses, it leaves a vacuum behind, and air pressure is able to push it up. Now the question is, how high can it push it up? Well, I'm going to pull out that glass tube and replace it with this glass tube. It's at least a foot long. Much, much longer. There we go. And let's pop that in there. And put that on the fire, on the heat. And do you think, if I invert this, do you think it will go up? What do you think? What's the verdict? Will air pressure be strong enough to push water up like 1 foot or 33 centimeters? So it's boiling now. The water's turning into steam. I can sort of hear a little bit of popping and noise here. I mean, what you have to remember is that as the steam goes up, it cools down and then it will condense. But then when the tube becomes hot, then the steam comes out. So there we go. Perfect. And it's ready to try. So I'll just hold that with the peg and this with the okay, here we go. I'm going to go this way around. Ready, set, upside down, and like so. And watching. And woo! It did it again. Now I knew it would do that because in actual fact air pressure is so strong it could actually pump up water 30 times that distance, 30 feet or 10 meters. Air pressure is a very strong force, and I don't have a tube that long, and my ceiling is certainly not able to do that, but air pressure is super, super strong. Okay, well, thanks for joining me today. Hopefully you enjoyed the lesson, and I look forward to seeing you again soon. Bye for now.